Linear inequality and number line. Today, we're going to solve some linear inequalities and show our answers in two different ways. First, by writing a linear inequality, and second, by showing the answer on a number line. Let's take a look at the first problem. Solve the inequality and graph the solution on the line provided. We have our two answer spaces here, first for the inequality notation, and second for the number line. We'll attack this problem the way that we attack most linear equations, solving. Negative 15 plus 6x is less than negative 27. I'm going to copy that into my workspace. Negative 15 plus 6x is less than negative 27. Okay, just like a linear equation, I'm going to go about solving this inequality by canceling information that's on the same side as my variable. I see that my variable is on the left, so I need to do something about this negative 15 and this positive 6. The negative 15 is a constant, it's all alone, so I'll cancel that first. To cancel a negative 15 constant, I will just add 15. And then to balance on the other side, I will do the same action, add 15. So let's do those actions. Negative 15 plus 15 cancels into nothing. Positive 6x gets carried down. I didn't do anything to the inequality symbol, so I'll keep it. Is less than. And then negative 27 plus 15 gives me negative 12. Okay. It looks like I have one more step to do to solve this linear inequality. I see that I still have this coefficient of 6. To cancel a coefficient, I divide by that coefficient. And to balance on the other side, I'll do the same action. Let's do those actions. 6 divided by 6 cancels into an invisible 1, leaving me with just x. The inequality, I didn't do anything to it, it stays the same. Negative 12 divided by 6 is negative 2. So now I have a solution in inequality notation. I'm going to type that into my answer space. X is less than negative 2. You can find the is less than symbol on your keyboard above the comma and the period. Now, to figure out how to represent this on a number line, I'm going to use my number line and inequality skills from before. I know that I'm going to have a boundary, a dot, at negative 2, so I'll start by clicking there, but I won't release yet. I'm going to then drag in the direction of the inequality symbol that I wrote above. So this was a less than. It's going to point me to the left of my screen. Okay, I've gone and highlighted everything from negative 2 all the way to the left and over onto this arrow to show that it goes on forever. But I'm not quite done yet. I need to check to see if this dot should be an open circle or a closed circle. Now I might remember, or I might look up on my reference sheet, that a less than or a greater than symbol is represented on a number line with an open circle. So less than or greater than symbol goes with open circles. Since this was a less than, I need an open circle. So let me click on that, and it's good. Let's submit these answers. Good. So I solved this inequality, and I showed my answer in two ways, with a number line and with inequality notation. Let's take a look at two more examples. Okay. Again, it's asking us to solve the inequality and graph the solution on the line provided. And the inequality that we're given is 6 plus 2x is greater than or equal to 16. Let's copy that down into our workspace. 6 plus 2x is greater than or equal to 16. Okay. I keep myself organized with my lines around my inequality symbol. And I can notice that, again, my variable is on the left, and so I need to cancel other information that's on the left. 6 plus 2x, well, I can get rid of this 6. It's a constant. I'll get rid of it first. To cancel a positive 6, I subtract 6. And to balance on the other side, I do the same action. So let's do it. 6 minus 6 cancels. Positive 2x can be carried down. The greater than or equals to symbol gets to stay the same. I didn't do anything to it. But the 16, well, I subtracted 6 from it. 16 minus 6 is 10. Okay, one more step. Cancel that coefficient. Divide by 2 to cancel the coefficient on the left, and divide by 2 to balance on the right. Okay, the 2 over 2 cancels into an invisible 1, leaving us with just x. We didn't change the inequality symbol at all. It still stays greater than or equal to. And then 10 divided by 2 is 5. Okay, looks like we have a solution in inequality notation. X. Ooh, now how do I write this? Well, there are a couple of ways. They give you a button here, so you can just use this button to show an or equals to symbol, or there's also a little shortcut on your keyboard. You can use the just greater than symbol on your keyboard, that's the one above the period, and then you can use the equal sign. Mine is right next to my backspace. By doing first greater than and then equals to, it merges, and most programs that allow you to type math will do that for you. So it's a pretty handy trick. Either way, I've now started this inequality notation of x is greater than or equal to, and I can finish it off with the 5. Now, how do I go about graphing that? This 5 is my boundary, so I'll make sure that there's a dot at the 5. I click that, and now I need to drag either to the left or the right. I see that it's a greater than or equals to. It looks like the arrowhead is pointing to the right, so I'm going to drag my green arrow until there's an arrowhead pointing to the right. So that's the right direction, but is it open circle or closed circle? Well, again, we might remember this, or we might look back at our references. Anytime we have a less than or equals to, or a greater than or equals to, we're going to use closed circles. So the circles on our graphs will be completely filled in. So I'm going to keep this as a closed, completely green circle, and I'll submit my answers. Okay, it seems like that's good. The number line and the inequality matched. Let's take a look at one last example. Solve the inequality and graph the solution on the line provided. 3x minus 9 is greater than or equal to negative 21. Okay, let's copy that into our workspace. (3x minus 9) is greater than or equal to negative 21. And I'll use these lines to just organize myself around the inequality. 3x minus 9. My variable is on the left, so I need to cancel other things that are on the left. I have this 3 and this negative 9. The first thing that I should cancel is the constant, the negative 9 that's not directly attached to the x. So to cancel that negative constant, I will add. So plus 9 on the left to cancel, and then plus 9 on the right to balance. Do those actions and see what we get. 3x, we didn't have any actions, so it just copies down. Negative 9 plus 9 cancels into 0. Greater than or equals to, we haven't changed. And negative 21 plus 9 we can combine those to get negative 12. Okay, one more step to solve it. Divide by the coefficient. So we divide to cancel the coefficient on the left, and we divide to balance on the right. Do those actions. Cancels into an invisible 1, leaving us with x. Greater than or equals to didn't change. And negative 12 divided by 3 is negative 4. Great. We have a solution in inequality notation. X is greater than or equal to negative 4. Now, graphing that on my number line, negative 4 is my boundary. So I'm going to hit negative 4, click it, and then drag in the correct direction. It's a greater than or equals to. The symbol looks like it's pointing to the right, so my arrow should also point to the right. And there we go. Both our inequality notation solution and our graphed number line solution were correct. So to recap, when we're solving linear inequalities, we're going to basically follow the same steps that we would solve a linear equation with. However, once we're done and we have a solution, we're also going to need to graph that solution because there are many ways to represent this information. Let me know what your questions are, and good luck.